get to see images on unprecedented levels of detail.
And it'll be the first ever mission to get in and see and touch what's coming from the sun.
Solar Orbiter is going to get the closest pictures of the sun that we've ever seen. It's even going to allow us to see the north and the south poles of the sun.
We've never seen them before, so this will be a completely new thing.
But it's not just about taking cool photographs. This is all about measuring the sun's behaviour as well.
We've got a combination of telescopes which look at the surface of the sun and really see what's going on, and then a suite of instruments which measure the solar wind, which is what is thrown off the sun all the time. So the extended atmosphere, if you like, of the sun.
It can be steady, it can be fast, it can be very eruptive, and it will be looking at all those different sources and trying to understand where it comes from and how it propagates towards us at Earth.
And the other great thing about it is that because we're going so close, we get to co-locate with some surfaces of the sun. Usually when we look at the sun, it rotates underneath us, so we just see parts coming past. With Solar Orbiter, we'll get to hover over one section and really see how it develops.
Because it's taking photographs of the sun, and the sun is really bright, Solar Orbiter's not going as close to the sun as other spacecraft. It's hanging a bit further back, 42 million kilometres away. And there it'll use telescopes to take pictures through the heat shield, a heat shield which is partially made of baked animal bones. It's all to help Solar Orbiter withstand temperatures of up to 600 degrees Celsius. That's 1,112 degrees in Fahrenheit.
It's very important to keep Solar Orbiter spacecraft and the instruments as clean as possible. And when there's dust on the lenses of the telescopes, when you expose that to the sun, it effectively bakes those particles onto the lenses. Once you start doing that, you start losing science. So it's essential to keep those instruments as clean as possible.
By measuring and capturing images at the same time, Solar Orbiter is really going to give us a good understanding of how the sun behaves, and how that can affect the technology we use here on Earth.
In today's world, with all our technology, if coronal mass ejection happens on the sun and affects us here on Earth, it's going to have an impact on things like satellites, global navigation systems, even televisions.
Exploring space is expensive, but the things that can happen from the technology spin-offs from this mission, we don't know what those will be yet, but there's been a lot of development that will undoubtedly have applications to us in everyday life in 10, 20 years' time.